Hello students, today I'm going to explain you how to find the moment of inertia and the product of inertia of a rectangular lamina. So similar as the rod, we have find at the corner and at the center of the rod. So in this case also we are going to find the moment of inertia and the product of inertia at the corner of a rectangle as well as at the center of the rectangle. So I'm going to explain you how to find the moment of inertia and the product of inertia at the corner of a rectangle. So first of all, I'll try to find the moment of inertia about the x-axis. So to find the moment of inertia about the x-axis, I'll consider a strip parallel to the x-axis. And the mass of this whole rectangle I'm taking as capital M, and the length of the rectangle I'm taking as 2a, and the breadth of the rectangle is taken as 2b, and the breadth of the rectangle is taken as 2b. So I'm considering this strip PQ. The thickness of this strip is nothing but it is delta y, and the length of this strip is nothing but it is 2a. So I'm taking a point C since it is lying in a plane xy. So the coordinate of this point is x comma y comma 0, and the mass of this point is nothing but it is m, where m is nothing but the mass per unit area. So if you revise what we have done last time, we have done about to find the moment of inertia of a uniform rod. In that case, I have taken as mass per unit length because it is lying in one dimension. So anything if it lie in two dimension, we are going to find mass per unit area. If it is lying in three dimension, we are going to find mass per unit volume, and so on. So we are going to proceed in this way. So here, since this figure lies in two dimension, or it lies in a plane, we are going to find mass per unit area. So here we have m equal to mass per unit area. So mass per unit, so mass of this rectangle is capital M. So the area of this rectangle is length into breadth, so 2a into 2b. So we get here m by 4ab. So this one I have explained you already. Now we are going to find what will be the mass of this strip PQ or the element PQ. So the mass of the element PQ is nothing but the mass at the point C into the area of this strip PQ, or the area of this element PQ. The mass of the mass at the point C is nothing but small m, and the area of this rectangle, but it is from a rectangles. This strip PQ is also a rectangle, so we'll try to find the area of this small rectangle. So the area of this small rectangle is nothing but it is length into breadth. So length is 2a and the breadth is delta y. So we have here 2a delta y. M is nothing but mass per unit area, so we have m by 4a. This is nothing but mass per unit area, so we have nothing but m by 4ab, m by 4ab 2a delta y. So here we try to cancel, then we get m by 2b delta y. So do we have this? This is your A, that is the moment of inertia about the x-axis. We have the formula summation delta my square plus z square. Then we try to put the coordinate of z as 0 because the coordinate of C is xy 0. So z is 0, so you substitute here z in place of z, we substitute 0, so we get here summation delta my square. We'll try to substitute the value of delta m as m by 2b y square dy. Now how to find the limit of this? So let us go back to the diagram. So to find the limit of this, so you see here we are considering a small strip parallel to the x-axis. So if I consider many strips parallel to the x-axis, then it will be lying, if we divide the whole rectangle into strips. Okay, if we divide the whole rectangle into strip, so the strip will be along the y-axis. Okay, the length of the means it will go along the y-axis. So if you look, the range of the y-axis is nothing but it is from 0 to 2b. It is nothing but from 0 to 2b, so that's why we are taking the limit to be nothing but from 0 to 2b. So here the limit is what? 0 to 2b, m by 2b y squared dy. So m by 2b is a constant. We come out of the integration and we try to integrate y squared as usual. So if after integrating and applying the lower limit and upper limit, we'll get the moment of inertia is nothing but it is 4 by 3 mb squared. Okay, now we'll try to find the moment of inertia about the y-axis. To find the moment of inertia about the y-axis, we are trying to consider a strip parallel to the y-axis. So here I'm taking a strip PQ parallel to the y-axis. So parallel to the y-axis, and the thickness of the strip I'm taking as delta x, and the distance from the y-axis to the strip is taken as x. So if I take any point in the strip, the coordinate is xy0, and the mass, okay, if I take the mass of this point is nothing but m, which m is nothing but the mass per unit area. So mass per unit area, so that is capital M divided by 2a into 2b, that is m by 4ab. So here we'll try to find what will be the mass of the strip PQ, or the element PQ, that is donated by delta M. This is nothing but mass of this point into area of this small rectangle. So mass of this point is M, so area of this rectangle is nothing but 2b into delta x. So we have here 2b into delta x. We will substitute the value of M, so m by 4ab, 2b delta x, which here we get as m by 2a delta x. So here we are trying to find the moment of inertia about the y-axis. So we have the formula of moment of inertia about the y-axis to be nothing but delta m z square plus x square. Z coordinate, we know it is 0, you put here 0, so we get here delta m x square. Delta m x square, so we'll put the value of delta m, so delta m is m by 2a. Delta x, so delta x we are writing as dx here, and the distance is x square, so we write here x square. Okay, so first of all, how to find the limit of this? So what we'll do, we try to take we'll divide. Okay, we'll try to divide this rectangle into small strips. We try to divide this rectangle into small strips. So we are dividing this rectangle, and this strip is lying along the x-axis. So the range will be along, means the limit will be along the x-axis. So you know that the limit, the range of x is from 0 to 2a. So that's why we are choosing the limit to be nothing but from 0 to 2a. So we have here m by 2a x squared dx. So m by 2a is a constant, will come out of the integration, and we try to integrate, and this we get as nothing but we get as 4 by 3 ma squared. That is the moment of inertia about the y-axis. So here we are trying to find c, which is nothing but moment of inertia about the z-axis, which is equal to summation delta m x squared plus y squared, which is equal to summation delta m x squared plus summation delta m y squared. So delta m x squared, I will try to find what is delta m x squared. We have already derived here summation delta m x squared, and summation delta m x squared is nothing but it is 4 by 3 ma squared. So we're going to put this value, and summation delta delta my square, we are going to put this value also. So summation delta my square is nothing but it is 4 by 3 mb square. We are going to put these two values here. So we put that summation delta mx square, summation delta mx square plus summation delta my square values. So we get here 4 by 3 ma square plus 4 by 3 mb square. So we are trying to take common from here. So if we take common here, we get 4 by 3 ma square plus b square, which is nothing but the moment of inertia about the z-axis. Now we'll try to find the product of inertia in about the three planes, about the xy plane, yz plane, and zx plane. So d is nothing but the product of inertia about the xy plane. So here we have the formula for d, that is summation delta m by z. But z coordinate is 0, you can substitute 0, and we get the product of inertia to be 0. In the same way, e also, we put z here 0, then we get it 0. But f, we get delta m xy, so it is not 0 in this case. But we try to find what will be the product of inertia in this. So to do this, we'll try to consider a particle c, and to find the product of inertia about f, you have to consider a system consists of only one particle. So consists of a particle c xy0, and we can always, if there is a particle whose coordinate is this, then we can also find a particle whose coordinate will be x minus y0. So we have, I'm considering only two particles, and we'll try to find the product of inertia of these two particles about the zx plane. So that is f equal to summation delta m xy. Now we'll try to find what will be the product of inertia about for the point C. That is nothing but x into y. So we have here delta m x into y, and here we have x into minus y. So we have x into minus y. Okay, so this one we get summation delta m xy. So here is plus into minus, we get minus summation delta m xy. So this is minus plus, this is minus, so these two will cancel, and we get nothing but 0. So that is the product of inertia about the zx plane. So this is the product of inertia and the moment of inertia about the corner of the rectangle. And I've given you one homework, so please do this homework. That is nothing but to find the moment and the product of inertia of a rectangular lamina from the center of a rectangular lamina. So the diagram will be somewhat like this. The axis will be passing from the center. Okay, so only the difference is that wherever I have taken as 0 to 2b, you can take as minus b to b, the limit. Just follow the same thing like how I have done. Just take only the limit as minus b to b, and the limit for where I have taken as 0 to 2a, you can take as minus a to a, and others will follow the same thing. So please do this question, and if you have doubt, you can ask from me. Thank you.